Hi there. In section 4.4, we are looking at right triangles. And what we're doing with these right triangles is we are going to be solving them. What it means to solve a right triangle is to find all three angle measures and all three sides. Now, just to familiarize ourselves with the right triangle, looking at the one here we have on the page, our three side lengths are always marked with lowercase letters. We have a lowercase a lowercase b, and a lowercase c. Across from side C is always going to be angle C, and that's always going to be a right angle. So we never have to find the measure of angle C because we are always going to know it. And then the other thing you always need to keep in mind is the capital letter is always going to be across from its lowercase counterpoint. So if side A is this vertical, that means the angle across from it is going to be angle A. And then where you look at side B and then you go opposite of that would be angle B. So the B's, as you can see, are across from each other, and the A's are across from each other, and so are the C's. Okay, so now, the first case we are going to look at, and I'm going to do this video in two parts, and this video is going to be all about case number one, where two side lengths are being given to you. And you can notice in example A, when we look at it, we see lowercase a is equal to something and lowercase b is equal to something. That tells us that this falls under case number one. The first thing I need to do when I start this problem is draw my right triangle. So as best as I can, I'm going to draw a right triangle. And that's going to be as close as we're going to get it. So I know this is always going to be my angle C. And then you can let A and B be in either place. And like we said, side A is going to go across from angle A. So I'm going to write in that 4.5 across from my angle A. And I'm going to write my B of 6.3 across from my angle B. Again, notice that the B's are across from each other and the A's are across from each other. So first thing we can find easily is going to be side C. Now recall, if we know two of the three sides of a right triangle, how can we find that third side? Right, we want to use the Pythagorean theorem. So that's what the step one up here says, find the third side by Pythagorean theorem. So we have to do a squared, which is 4.5 squared, plus b squared, which is 6.3 squared, equals c squared. Now instead of writing c squared, we could do that. And then to get rid of that squared, we have to take the square root of both sides. So now we have the square root of 4.5 squared plus 6.3 squared equals c. And now we're just going to type that into our calculator, 4.5 squared plus 6.3 squared. And then when we press enter, we're getting 7.7. I'm going to keep 2 sig digs since the other ones had 2 sig digs, equals c. So now we know all three sides now. So I know little a is 4.5, I know little b is 6.3, and now I know little c is 7.7. Now I want to find my three angle measures. So now these are all noted with capital letters, A, B, and C. Well, we know C is 90 degrees, so now we need to find the measure of the other two. So you can see step 2 up here says find one angle using an inverse trig function. It doesn't matter whether you want to start with angle A first or angle B first. All right, so let's just start with A. So now when we want to start with A, we need to look at the two sides that we know. And if you look at this A and go across from A, we can see that this is what we call the opposite side. And we will look right next to the A, this is what we call the adjacent side. So we know the opposite side and the adjacent side. This is where we're going to use the acronym SO, CA, TOA. And you probably have heard of this before. What this means is the SO means when we have sine of our theta, that is equal to the opposite side over the hypotenuse. Well, that doesn't help us because we don't know the hypotenuse. We did find the hypotenuse, but we only ever want to use the values that are given to us in the original problem. So now, what the CA stands for is cosine of theta is equal to the adjacent side over hypotenuse. Again, we know the adjacent side of A, but we don't want to use the hypotenuse. So lastly we have is TOA, which is going to be tangent of theta is opposite over adjacent. Now this we know because from angle A, we know the opposite side is 4.5, the adjacent side is 6.3. So I want to use tangent. So I'm going to set this up as tangent, and you always have to follow the trig function with an angle. We want to look at angle A. So tangent of A is equal to the opposite, which would be 4.5, divided by its adjacent side, which would be the side right next to it, which would be 6.3. Now we have to find what angle A is. Just like we talked about in the last section, anytime you have to find an angle measure, you have to use the second button to get that inverse. So we want to press second tan and then type 4.5 divided by 6.3. So again, what your calculator is going to look like is tangent, and then when you press the second, you got that little -1 there. And then we have 4.5 divided by 6.3. And when you press enter here, we're getting a value of 35.5376777 and so forth. I'm just going to leave it as 5377 for now until we talk about our rounding. And so that means that angle A is going to be that angle measure. Now, when we talked about the chart the other day, we talked about that if a side length has 2 sig digs to it, that means we want to round to the nearest angle measure. So 35.5 would round up to 36 degrees. Now, to find angle B, we could just do 90 minus 36, but in case we made a mistake there, it's best to just use another trig function and do the same thing we did in that step. So now I'm going to do that same thing, but now I'm going to use angle B as my starting point. Again, if we want to find out if we have the opposite, adjacent, or hypotenuse, well, this is our hypotenuse. We weren't given that value, so we're not going to use anything that works with a hypotenuse. So we're just going to look at the opposite and adjacent. So notice at this time, the opposite is the 6.3, the adjacent is the 4.5. So now again, I'm going to use tangent, but this time of angle B. Opposite of angle B is 6.3, adjacent to angle B is 4.5. So now in the calculator, I'm going to type second tangent again, and then type 6.3 divided by 4.5. So it's almost the same as last time, but just my numerator and denominator are in opposite spots. And now I'm getting an answer of B is equal to 54.4623, so forth. And if we want to round the nearest angle measure, we know it would be 54 degrees. So therefore, now that we have all 6 of our measurements, we know we have solved the right triangle. Now, when we look at example 2, we'll notice that we are given side C, but also an angle A. We're going to skip over this one for the next video because I just want to look at the ones where 2 side lengths are given, just like in the first example. So let's go to the next page. Well, now when we look, we see little b and little c. So here, 2 side lengths are given. So first thing we want to do is I want you to draw the triangle and label it with your sides and your variables. So go ahead, pause the video, draw your triangle, and do all your labeling. Okay, so what I did here, this is how I'll start off with all my problems. I draw my triangle. I always label my A, B, and C. This is the order I always do. C always has to be the right angle. A and B could be flip-flopped, but I always do it like this. And then my little b, so the side is always across from the angle B. And side C is, in this case, it's going to be the hypotenuse. And then I also have over here my ABC of my sides, and then my capital ABCs of my angle measures. And I filled in everything that was given to me. So now, first thing, we want to find our missing side by using the Pythagorean theorem. Notice this time we are not finding the hypotenuse, but we're finding one of the legs. So what I want you to do now is pause the video and find that side length. Okay, when we did this, first thing I did a squared plus b squared equals c squared. I have to move my b squared to the other side. So I get a squared equals that difference, and then take the square root of both sides to get 11.4. I rounded to 11.4 because I noticed that both the other 2 sides had 3 sig digs, so I wanted to keep it consistent. Now we want to use our trig functions to find a and b. It doesn't matter which one you start with. I'm going to start with angle A. So now we want to look at the two sides that we have and figure out which trig function we need to use. Remember, SO, CA, TOA will help us determine which side to use. Well, when we look at 7 in relation to A, this is what we call the adjacent side because it's next to it, whereas 13.4 is going to be the hypotenuse. So if we have adjacent and hypotenuse, we want to use the trig function that uses adjacent and hypotenuse, which, right, that would be cosine. So now we want to set it up as cosine of A. Again, you always have to have an angle following your trig function, and the adjacent side would be 7 over the hypotenuse would be 13.4. Now this is when we type in our calculator, second cosine 7.00 divided by 13.4, and we're getting 58.5. And think back to our table from the previous section, is if you have 3 sig digs at your side, you round to the nearest tenth, so we know angle A is 58.5 degrees. Now, we have to find our third angle measure. What I want you to do is pause the video and see if you can figure out from angle B which trig function you need to use, and then type it in your calculator to see if you can find the measure of angle B. Now I found the measure of angle B to be 31.5 degrees. Now here I used sine. That's because when we're at angle B, again, we know the 7 and the 13.4. We know this 13.4 is the hypotenuse. Now the 7 is opposite of B. So if we have opposite and the hypotenuse, that would be the sine trig function because OH is opposite and hypotenuse. So sine of B is equal to the opposite of 7 over the hypotenuse, which is 13.4. And then we type in our calculator, second sine of 7 divided by 13.4, and we get 31.5. Now, we can always check our answers because if we were to add up A and B, they should always add up to 90 degrees together, which 58.5, if we type it and we add 31.5, we know we are getting 90 degrees. So now what I want you to do is I want you to pause the video and look at the next 3 examples and figure out which one of those is giving us 2 side lengths. Right, looking at these, example 5 gives us 2 side lengths. Again, we know this because it's given us 2 lowercase letters, whereas here it's giving us an angle in example 4, and example 6 is also giving us an angle. So now, since we know example 5 is when it's giving us 2 side lengths, what I want you to do now is see if you can work through all of example 5 from start to finish by yourself. And then when you're finished, unpause the video and check to see how you did with me. Okay, just to make sure you're off on the right track, we want to make sure you have it set it up correctly first. We have our right triangle with angle C. We know side C is 3500, which that's always going to be the hypotenuse no matter what. I have angle A down in the lower left, and across from that is side A of 1500. Good. So now that you have that good, go ahead and pause the video again and keep going. First step is you had to find your missing side using the Pythagorean theorem. And when we type it in, we get 3,162.27766. However, we only want 2 sig digs, so we would round that to 3,200. All right, so now once you have that, go ahead and start finding your angle measures. Okay, first one we find is A. So we have the opposite side, because from A, this 1500 is opposite, and we have the hypotenuse. Well, we know sine uses the opposite and hypotenuse. So we hit the second sine, 1500 divided by 3500, round it to the nearest whole degree, we'd get 25 degrees. Good, now do the next measure. Okay, so now for cosine of B, again, we're at B, 1500 is the adjacent side with the hypotenuse. Adjacent hypotenuse is the cosine, so cosine of B, 1500 divided by 3500, and that would round to the nearest degree of 65. And again, 25 plus 65 do give you 90. So that would be solving this right triangle. All right, well, that's all I'm going to have for this first part of the video. The second part of the video will cover the situation if we are given a side and an angle measure. Please reach out if you have any questions, and good luck on the homework.